Good morning, my dear students. So, Determinants Part 2. So, in last Part 1, I discussed this formula A into adjoint A is equal to adjoint A into A is equal to det A into I. So, from this result, we will get A inverse is equal to what? 1 upon det A into adjoint of A. Okay. So, when this A inverse is exist are meaningful when this determinant A not equal to 0. If det A is equal to 0, then A inverse does not exist. See, something by 0 is undefined. So, A inverse does not exist. Okay. So, here the definition, one definition, if a square matrix capital A is said to be singular matrix, if det A is equal to 0. That means A inverse does not exist, because if det A is equal to 0, 1 by 0 adjoint A, it is not defined only. No? So, A inverse does not exist. So, or A is not invertible matrix. So, if det A not equal to 0, then A is called a non-singular matrix, then A inverse exists and A is an invertible matrix. Okay. So, now some formulas. So, inverse of a square matrix. See here. So, A into A inverse is equal to A inverse into A is equal to what you will get? Identity matrix. Okay. AB whole inverse is equal to B inverse into A inverse. And from this, from this adjoint of A is equal to what you can write? Det A into A inverse. Det A into A inverse. Next, how to find inverse of adjoint A? Inverse of adjoint A is same as adjoint of inverse of A. So, adjoint of A inverse. Again, from this formula, in this formula, you replace A by A inverse. Then what you will get? Det of A inverse. A inverse whole inverse is A. But det of A inverse is nothing but 1 upon det A. Remember, det of A inverse is equal to what? 1 upon det A. So, thus adjoint of A whole inverse or adjoint of A inverse is what? A upon det A, or 1 by det A into A. And here, from here onwards, I am discussing whatever the A matrix is there, that is a square matrix of order n. So, adjoint determinant of Ka is equal to K power into det A. Determinant of adjoint A is det A power n minus 1. N is what? Order of A. So, adjoint of adjoint A is here is equal to det A power n minus 1 whole square. Adjoint of adjoint A. Determinant of adjoint A is equal to determinant of det A whole power n minus 1 whole cube. So, you can remember easily. A determinant of adjoint A is there. So, how many adjoints is there? Only one. So, det A power n minus 1 whole power 1. So, adjoint, here determinant of adjoint A. So, how many adjoints are there? 2. 2. Det A power n minus 1 whole square. N minus 1 whole square. So, determinant of adjoint A. How many adjoints are there? 3. So, det A power n minus 1 whole power 3. So, determinant of adjoint A. 4 times is there. It is what? Determinant of A whole power n minus 1 whole power 4. Okay. Next important formula, adjoint of Ka is equal to K power n minus 1 into adjoint A, where K is some constant. For example, adjoint of 2A is equal to 2 power n minus 1 into adjoint A. And already you have learned this also from theory. Adjoint of AB is equal to adjoint B into adjoint A. So, after this, I am going to discuss consistent and inconsistency of the given system of non-homogeneous equations and homogeneous equations. So, when we say that a given system of equations is consistent if it has if it has a solution, it may be 1 or 2 or infinite. Okay. Next, when we say that given system of equations is inconsistent if what we call no solution. Okay, if the given system of equation has no solution, then the given system will be inconsistent. Consistent means has a solution. Inconsistent means has no solution. Okay. Next, you consider system of non-homogeneous equations. System of non-homogeneous equations. So, like a1x plus b1y plus c1z is equal to d1, a2x plus b2y plus c2z is equal to d2, and a3x plus b3y plus c3z is equal to d3. Okay. So here, at least one of these three constants not equal to 0, then given system is non-homogeneous. Okay. So homogeneous means here all these constant terms becomes zeros. Okay. That means here now I am considering non-homogeneous means at least one of these d1, d2, d3 must be not equal to 0. Okay. So now you take a delta is equal to determinant of coefficient matrix. Determinant of coefficient matrix. So what is the determinant of coefficient matrix? A1, B1, C1, det of A2, B2, C2, A3, B3, C3. And you define delta 1 is equal to, replace first column elements of delta by constant values. What are the constant terms? D1, D2, D3. And remaining two columns as it is. So similarly, delta 2, you define delta 2, you take delta 2 as, replace second column elements of delta by constant terms, remaining two columns as it is. So A1, A2, A3, so we do D1, D2, D3, C1, C2, C3. So similarly, what will be the delta 3? Just replacing third column elements by constant terms. So remaining two columns as it is. Okay. So now you define like this. Then on solving these three equations, you will get x value delta 1 by delta, y value delta 2 by delta, z value delta 3 by delta. Means on solving these three equations, some expressions will get. Those expressions are nothing but numerator expression is the same as delta 1 for in case of x, denominator is delta, and in case of y, so that numerator expression is nothing but delta 2, numerator number or the expression nothing but delta 2, denominator is delta, and for z numerator is nothing but delta 3, and delta 3 if you expand whatever you will get determinant, that value only, denominator is delta. Okay. So now clearly we can say that this system of equations has unique solution if delta not equal to 0. Unique solution if delta not equal to 0. If delta not equal to 0, x, y, z all are exist. So whatever you are getting those values, whatever you are by substituting delta 1, delta 2, delta 3 and delta values, then you will get x, y, z values. That means the given system of equation has unique solution. Next, suppose second case. Suppose delta is equal to 0, delta 1 is also 0, delta 2 also 0, and delta 3 is also 0. Then given system of equations has infinitely many solutions. Infinitely many solutions. So infinite solutions. Infinitely many solutions. So how we can say it has infinitely many solutions? See here, x is equal to what you have, delta 1 by delta. So just for one case I'm taking, okay. X is equal to delta 1 by delta. This can also be written as delta into x is equal to delta 1. Is it correct? Am I correct? Okay. Now, what we got delta value? 0. What you got delta 1 value? 0. Now, here we need to find x value. We need to find what? X value. So, 0 into what kind of real number? X is equal to delta 1, 0. 0 into which number is equal to 0? So, 0 into any number is equal to 0 only, because already delta value 0, delta 1 also 0. So, this value 0, this value also 0. We have to find what? X value. Okay. So, instead of x, if I substitute any number, then this equation is satisfied now. That means x takes how many values? Only one value or more than one value? So it takes infinitely many values. So there exist infinitely many x such that delta into x is equal to delta 1. So then how many x values we are getting? Infinitely many values. Similarly, how many values for y? How many values are taken by y? Infinitely many values. And how many values taken by z? Infinitely many values. So thus we can conclude given system of equations has infinitely many solutions. So because here x, y, z takes infinitely many values. Okay, in which case delta 0, delta 1 0, delta 2 0 and delta 3 0. That means all these four determinants are equal to 0. Next case, suppose delta 0 and at least one of delta I not equal to 0. At least one of delta I not equal to 0, where I is equal to 1, 2, 3. That means either delta 1 not equal to 0 or delta 2 not equal to 0 or delta 3 not equal to 0. So then in this case, what we can conclude, the given system of equations has no solution. Given system of equations has no solution. So how we can say it has no solution? Again, you consider this equation delta into x is equal to delta 1, because x value what you got? Delta 1 by delta. From that we can write x into delta or delta into x is equal to delta 1. So here delta value is basically what we got in this case 0, and this value is what? Not equal to 0. Then is there any number 0 into that number is a non-zero number? 0 into that number is equal to a non-zero number. Such a number x is exist? No, does not exist. So that means x value we can't find. In this case x value does not exist. Y value also does not exist. Similarly z value also does not exist. So that means in this case what we can conclude, given system of equations has no solution. Okay, that was the explanation. So you have to remember delta not equal to 0, unique solution. As it has a solution, it is in this case system is consistent. And in this case delta 0, delta 1 0, delta 2 0, delta 3 0, then system has infinitely many solutions. So system has a solution means what? In this case also the system is consistent. And in this case delta is equal to 0 and at least one of delta I not equal to 0, then the given system has no solution. So if system has no solution means that system is inconsistent system. Inconsistent system. So this is about homogeneous equations, non-homogeneous equations. This is about non-homogeneous equations. Here I have taken example here, 3 equations, 3 unknowns. In case of 2 equations, 2 unknowns also, same thing. Okay. So in that case, we'll get delta, delta 1, delta 2, because 2 equations, 2 unknowns only, no? Next, homogeneous equations. Homogeneous equations. So remember, homogeneous equations are always consistent. That means it has always a solution. See, by putting x value 0, y value 0, z value 0, every equation is satisfied with these values of x, y, z, irrespective of ai, a1, a2, a3, b1, b2, b3, c1, c2, c3, irrespective of coefficients. Okay, if I put x value 0, y value 0, z value 0, every equation is satisfying. So a1 into 0, 0, b1 into 0, 0, c1 into 0, 0, 0 plus 0 plus 0 is 0, so 0 is equal to 0, satisfied. So that means homogeneous equations are always have at least one solution. So in this case actually it has either one solution or infinitely many solutions, only 2 cases. In case of non-homogeneous, 3 cases, unique, infinite, no solution. But in case of homogeneous, only 2 cases, unique or infinite. So that means if it has unique solution or infinitely many solutions, unique solution or infinitely many solution, both cases the system is what? Consistent. Okay. So this x value 0, y value 0, z value 0, this solution is also called trivial solution. Trivial solution. So other than these values of x, y, z, if any other x, y, z values are satisfying this system of equations simultaneously, so that solution is called non-trivial solution or non-zero solution. Non-trivial solution or non-zero solution. So if we can find there exist x, y, z among those three numbers, at least one of them not equal to zeros, and satisfying all those values, satisfying those x, y, z values, these equations, then the solution, if such solution is exist, then automatically we can find infinitely many values x, y, z satisfying the given system. That means the given system has either unique solution or infinitely many solution. So if we find it has a non-zero solution, means automatically there will be infinitely many values of x, y, z satisfying the given system. Okay, so now I'm going to discuss in which case it has unique solution, in which case it has infinitely many solutions. So same delta, you take coefficient matrix delta of A1, B1, C1, A2, B2, C2, A3, B3, C3. So if delta not equal to 0, then it has unique solution. Unique solution. So what is that solution? Unique solution? X is equal to delta 1 by delta, y is equal to delta 2 by delta, z is equal to delta 3 by delta. In this case, delta 1, delta 2, delta 3 obviously zeros, because here what are the constant terms? 0, 0, 0. Then x value delta 1 by delta means anyway delta not equal to 0. 0 by delta 0. So y value also 0, z value also 0. So x value 0, y value 0, z value 0. But unique solution is what? X value 0, y value 0, z value 0. And this this solution is also called what? Trivial solution. And if delta is equal to 0, if delta is equal to 0, then in this case it has infinitely many solutions. Same explanation. So we can write del x into delta is equal to delta 1, as delta 1 obviously 0. In this case, if delta 0, then there will be infinitely many x values satisfying x into delta is equal to delta 1. So automatically there are infinitely many x, there are infinitely many y, there are infinitely many z satisfying these three equations. And here in this case, the system of equations has infinitely many solutions, and those solutions are nothing but non-zero solutions. Those solutions are nothing but non-zero solutions. Okay, so suppose in a problem, if it is given, they have given homogeneous equations, and if the given system of equations has non-zero solution, means you have to understand that that homogeneous system has infinitely many solutions. What you have to take condition? Delta is equal to 0. So for unique solution, delta not equal to 0. So in case of homogeneous, it has always at least this solution. So that's why the homogeneous system of equations is always consistent. Okay, so with this I'm going to close session 2 of the determinants. So with this, theory part is completed. In the next session I'm going to start problems in our material. Thank you.